Hey, PSTAT students, welcome to this week's assignment. The first thing we're going to do this week, hopefully you've taken a look at the top part of the assignment, and if you didn't get the earlier memo, that you can have a TI-84 calculator installed on your Chromebook by simply clicking on the link in the assignment, and once you install it, it functions just like a TI-84 on your Chromebook. And what you're going to do is once you have that program, you can go to the program on the Chromebook, and it says TI-84 on there, and all these buttons and functions are similar. That will help you a lot as we go through some of these assignments. So make sure you've done that, and then also make sure you've checked out that warm-up guess the correlation. So right now I'm going to talk through the introduction notes. Our topic last week was introducing this idea of bivariate data. Remember, bivariate data means we have two variables. So we have sort of an input and output, an X and a Y. So a lot of the data we looked at earlier this year was univariate data, which means we just have one variable. So right now we're going to think about situations where we have two variables. So if you look at those introduction notes, and you can either print those out, that might help you to print them out and sort of write the notes like you would in class. Or the other option is just kind of follow along on your screen. But it always helps me to write things out. So I would recommend that you take your own notes as we go through this. So those introduction notes says a scatter plot helps us see the relationship between two variables. So I'm going to click on the notes that I've already created as we look at this. 1 second. So if you take a look at the notes, it says this sort of data is called bivariate data, and that's what we just talked about. So in the notes, you have several blanks where you have places that you're going to think about what a scatter plot would look like. So if we have a scatter plot that has a positive direction, you could see this first one right here has a positive direction because as I go to the right, the dots in general are getting larger. A negative direction is this next one, and as you go to the right in general, the dots are going down. Now you notice it's not perfect. Some dots as you go across are bigger than other dots, but in general, it's getting smaller. If you have a scatter plot that has a direction which we would call zero, it's just flat, like a slope of zero. So that's the first thing, and I'll get rid of that. I'm still learning how to do all this, so you might have to bear with me a little bit. But then on the bottom there, we also have form of the scatter plot, and that's something else we want to think about as we describe a set of data. So form, in this next one, we have a linear form. So in general, the dots are approximately creating a line. And you can see the ones up top there are also generally linear. Definitely not perfect, but that's part of what you're thinking about it. It's not perfect. We're just looking roughly or approximately. And at the bottom, we have one that's slightly curved. This one is sort of linear, but you can see it's actually starting to go up more in a curve. So if I were to kind of show the general trend of that one, it might look more like that. It's kind of shifted over actually, but you get the idea. And then this last one, this random scatter, that would be no pattern. So I'm going to go back and draw this one also, roughly linear. So that's the idea with those. So that's the first part of your notes. And as we continue on, let me change it back to the pointer. So in the next section there, in your notes, after we've sketched those and thought about the form, 1 second. Oh, there's one other part there, outliers. So outliers are those points that generally don't follow the trend. They don't follow the general trend. So for instance, if I were to have in this negative one up here. If I were to have a point way over there, somewhere way over there, that would be an outlier. And you've already learned about outliers in univariate data sets, so you're familiar with that concept. Next up, let's go back to the next page there. So these are some definitions. So when explaining the connections between two variables, we often want to determine the roles that the variables play with each other. So a dependent variable or response variable, and actually we're going to go with response, but you could think of that as the dependent variable. This is the variable you hope to predict or explain. And that's like our output. So if we think about a function, this is our y value, and it would be along the y-axis. The independent variable, which we refer to as either the explanatory or predictor variable, this is the variable that you hope predicts or accounts for that response variable and the change in that response variable. So again, this is the input. This is along the x-axis or the horizontal axis. So some examples. Do baseball teams that score more runs sell more tickets to their games? So in that example, there are two variables. The two variables would be runs and tickets. So probably make more sense to think about runs. The more runs a baseball team scores, and the higher scoring they are, hopefully the more tickets they would sell. Perhaps there's a relationship there. So runs would be the explanatory variable, and tickets would be the response variable. At that bottom, in the bottom example there, do students who score higher on their ACT have higher GPA in college? So that one we would say ACT is explanatory, GPA in college is response. So wondering if I give you an ACT score, does we look at a student's ACT score, does that predict what their college GPA might be? So those are some definitions, and it's really important that you understand the difference between the response variable and the explanatory variable. On the AP test, they may ask you which one is which and why. So in the next section, if you keep going here in your notes, one second. My Chromebook's not moving real fast. All right, we have an example, and what we're going to do is kind of walk through actually the process of finding the correlation coefficient. So in the warm-up game called Guess the Correlation, that R value helps us determine the strength of the linear relationship. And one of the things to keep in mind is if you tried playing that game, the warm-up game, all those R values were always positive. However, if we have a scatter plot where the general trend is a negative trend, your R value would be negative. And so what I'm going to do is it's important that we understand where that R value comes from and how it's calculated. So in your reading in the textbook, they talked about standardizing the bivariate data. So what we're going to do when we standardize is we're actually going to find the z-score of all the inputs, and which are the explanatory variables, all the x's, and we're also going to find the z-score for all the y values, which are the predictor variables. So in this case, we're thinking about, I'm wondering, in general, students that have fewer absences, would they have a better grade? And so my response variable in this example, I would say, is absences. And my predictor variable, I would say, is percentage. So I'd say absences here, which I'm not going to be very good at writing there, ABS. And then we're going to say percentage would go here. So percent would go in the Y. And the next thing you're going to do, you're going to create a nice scatter plot here, and you're going to make sure you practice good graphing skills. You're going to label your X axis and your Y axis. Make sure you include a scale that counts by the same amount. and you would plot all of these points. Now we have a student with 2 absences that has an 84, so they would be somewhere up here. You have another student with 0 absences that has an 85, so they would be, I'm going to change the color a second. So student with 0 absences would be, right in here somewhere. And you have all these dots. So what we're thinking about, and this is not exactly what it looked like, but you get the idea. You could plot those points. So what we're wondering is, what kind of R value would this have, and how do we figure that out? So I'm going to walk you through that process right now. Okay, so what we're going to do is we're going to go to our TI calculator, and we're going to actually enter all of this data. There are 10 different students that we have here, and so we have 10 different coordinates. And so I'm going to show you what this looks like on the TI. I've entered the data in the TI. So if I go to stat, it says RAM cleared. So I don't know if it remembered my data. Oh, it didn't remember my data. Okay, well, I'm going to need to put that data in. So in L1, I would type in my absences, in L2%. So I'll do that a second. Okay, so I have the data entered in my TI calculator now. And so what I could do is if I go to stat and I press calculate, so I'm going to shift over to calc, and if I want to find my mean and standard deviation for X and Y, I'm going to go to 2var stats, and I've got L1 and L2. Those are the defaults. Press enter, and that's going to give me everything I need here. So I can see that the mean X is 3. And if you go through each of these, the only 2 we really need are the mean and standard deviation, because we're going to do Z-score. So we're going to do the X bar, and we're going to do S sub X, because we're doing sample standard deviation. We're assuming this is a sample. Remember, sigma means population standard deviation. So we're going to take each of these numbers. So the one number there, I'm going to write these down over here. So the one number is, I lost it. So X bar, I would say, is 3. And then the standard deviation of X, this is messy, I got to practice this, is 2.7. And that's rounded slightly. We try to avoid rounding as much as we can. And then you could do the same for the Y. So if we take a look at the Y, we have that the mean is 80.1 and that the standard deviation is 14.57. So what we're going to do is actually find the Z-score. I'm going to take those. So 80.1. I'm writing these down over here so that I remember them when we go back to I'm going to show you what else we can do in the calculator. So then the standard deviation of Y is 14.7. Not real clear there. There we go. 14.757, I believe it was. 57. Okay, so what I can do next is in my stat function. Now I'm going to go back to edit, and I know. First I want to make a scatter plot of this data, and I'm not sure if we've ever done this with 2 variables. So we're going to go to our graph. I'm going to go second y equals, and I'm going to say I want plot 1 on, and I want to make it a scatter plot. Let's make this a little bigger. So I want to make it a scatter plot, and that's the default, and we're going to use everything on there the way it is. And then if I press window, I need to adjust my window. So remember, we're talking about absences. So 0 is the lowest we have, and we go up to, I think the largest was below 10. And then if we go to our Y, and I'm going to go a little bit above just in case, so I'll go up to 15. In our Y, we're going to say the lowest percentage we can have is 0. 100 is the highest. Oops. So I'm going to go to 100 in my max, and I'm going to count by 10. And if I were to graph this, let's take a look. So you can see, I know what I want to do. I want to make sure I show a little bit to the left. So I'm going to go -1. Oops. go to? I didn't like that negative sign. Try that again. We'll do this negative. There we go. So if we press graph, you can see that scatter plot. And you can see this one is a negative linear relationship. It's definitely in the form of a line. It's definitely not perfect, but you see that linear relationship. We see that we have a student that was gone quite a bit, but still managed to get a decent grade. But in general, as you are absent more often, your grade goes down, which is what we would expect. We could also calculate the line of best fit and the R value right off the calculator, but I'm going to show you how this looks kind of by hand today. So if we click back on the stat and we say, I want to do in my L3 now, what we're going to do is calculate the z-scores for all the x's and the z-scores for all the y's. So to do those z-scores for all the x's, I'm going to say, I'm going to do, first of all, L2, or let's see, we're going to do L1. So I'm going to press second and then 1, and then minus my mean for L1, which was 3, divided by the standard deviation for L1, which is 2.7. And if I press enter, that will calculate all those z-scores for the x's. And I could do the same for the y's. So I'm going to press enter up there at the top, and same thing, I'm going to do second, L2 minus, and then my mean for my y's is 80.1, so I'm going to do 80.1 divided by, now the other thing is make sure you realize those parentheses are really important. If you don't put those in, you're not going to get the right z-scores. And then the standard deviation was 14, oops, I'm going to have to start over. Let's try that again. So second, L2, just like class, I make mistakes. So bear with me a second, 80.1, and then divided by 14.57. And we press enter, and that gives us all the y's. So this is a way that we standardize our x and our y values in a bivariate set of data. We're essentially finding the z-scores for each of those variables separately. And if we plot those, so first of all, let's take a quick glance at the first graph we made right here. And so if I were to save that, actually I'm gonna quick snip that so we can compare it. So if I were to take that screen, so I'm gonna keep that on the side as a reference, and now I'm gonna copy that, and I'm gonna just have us look at that after. So I'm gonna put that in a Google Doc for us so we can look at that, and then we're gonna look at the z-score scatter plot and talk about what we notice. So if we, one second. Okay, so I have this copied, and now what I'm gonna do is create a new scatter plot of the z-scores, and we're gonna compare those. So if I go back to my second y equals, so I'm going back to my scatter plot, and I'm going to change this. So I'm gonna go into scatter plot 1 or plot 1, and instead of L1 and L2, I'm gonna go in and change this to L3 and L4. So I'm gonna change first the x variable to L3, and then I'm going to go down and change the y variable to L4. So if we do that and we compare, I'm going to change the color just for fun to something else. And so if we also need to adjust our window. So remember, now we're talking about z-scores. So the biggest z-score we really could have is like -3 to 3, -3 point something would be crazy. So I'm just going to go, I'm going to go way out. I'm going to go -4. Whoops. Got to go back to that, go to. So I keep forgetting to use this negative. So -4 up to 4, and counting by 1 makes sense there. And then same with the y. We'll go -4 to 4, counting by 1. And if we graph this, let's take a look. And there you go. So notice that if we examine this graph, so again, I'm going to take a picture of this, and then I'm gonna put it next to the other one, and then we'll talk about that. Here we go. All right, so if we look at those two graphs, you can tell that they're identical. You can see that the blue, which was the original scores, and then when we standardize it and look at those red scores, the dots are exactly in the same spots. The only thing that's really changed is the scale. So relative to one another, they look exactly the same. So what I could even think about is if I were to draw right about in here and right about in here, an X and Y axis for this one, it would look just like this one. And that's one of the big ideas when we standardize is we're not changing anything about the points in relation to one another. What we're doing is we're adjusting them so that the mean and standard deviation are much easier to work with. So something for you to try is you can actually find the mean and standard deviation of these standardized scores. I might just spoil the fun for you right now and show you on my calculator. So if I go to stat and I say I want to calculate the two var stats, and this time I'm going to do it for L3 and L4. So I'm going to do second L3, and then we're going to go down here, second L4, and we find those statistics. Here we go. You can see that the mean of x bar is 0. The standard deviation is 1.0029. If we didn't round anything, it would be 1. Same with the y. The mean is 0. The standard deviation is, if we go down, very close to 1. Again, if we didn't round, it should be 1. So that's another big idea. When we standardize x and y, we get sets of data that have mean and standard deviation of 0 and 1. And these are the simplest mean and standard deviation that I could potentially, that I could ever get. The other thing is, if I found the R value of either one of these, they would be the same. So next, after you've calculated the mean and standard deviation of each of those, you would then go on. And so let's go back to our notes a minute. So in our notes, so what I pulled up is the formula sheet for the AP test. And under descriptive statistics, I wanted to point out what we're going to use here. So we have this formula for R right here. So if you look at this, it's on the outside, we have 1 over n minus 1. So n is the number of points that we have in our data set. Here, since we had 10 students, n would be 10. So 1 over 10 minus 1. And then we have this symbol. So this next symbol means summation. So the summation of the z-score for the x's times the z-score for the y's. So what we have to do there is actually multiply the z-scores together. Now, rarely will you ever need to calculate all this by hand. And on the AP test, you can use your calculator, but I think there's a lot of value in understanding where this R value comes from and how you calculate it. So that's what we're doing. So if we go to our calculator and we look at the data that we did with our z-scores. So in stat and in edit, we're going to go back there. So we have our z-scores for the x and our z-scores for the y. So in L5, what I'm going to do is I'm going to multiply together L3 by L2. So I'm just going to type in second L3 times second L2, or I'm sorry, L4. So I got to back this up. Try that again. Second L4, enter. And so we're multiplying these all together. And if you notice, these give you quite small numbers. And if you think about that, these are all real small numbers too. We're multiplying two small numbers together. And just a quick visual of what this is doing. So if I were to think about any graph, I'm going to make a quick sketch right here of the z-scores. Actually, you know what, even better, I'm going to go back to the document that we just looked at with the scores that we had. I'm giving my Chromebook all the work it can handle. It's going really slow right now. So here we go. Okay, so if we think about standardizing and think about those z-scores, it's coming in right now, almost ready. Okay, so we have 4 quadrants. So in those z-scores, when you think about those quadrants, depending on which quadrant we're in, we're going to get a number when we multiply in the positives, a positive number or negative. So if we think about the first quadrant, both x and y are positive in that first quadrant. So it makes sense that our z-score, when we multiply a positive times a positive, we get a positive. So anything in this area and also in this area down here, negative times a negative, that would also be a positive. That contributes in a positive manner. So if you have more points in these areas, you're going to end up with a sum that's more positive here. If you have more points that are in the negative quadrant, so a negative times a positive in either this second quadrant or negative times a positive over here in this quadrant, you're going to end up with more products that are negative when you do the z-scores multiplied together. So you can see in this one we have more that are negative. So let's go back to our calculator, and since if you counted all those up, there's definitely way more that are negative. There's only one that was slightly positive. So we're going to add all those L5 numbers together. So to do that, I'm going to quit out of here, and I'm just going to say second list, and I'm going to go to math, and I'm going to go to sum. So sum, and then I'm going to do second L5, and I'm adding together all of those. And when I do that, I get negative 7.956. And then remember, we had to multiply that by 1 over n minus 1 on the outside. So if I divide that by 9, because it was 1 over 9, and get that, I get negative 0.884. So that is my R value. It makes sense that my R value or correlation coefficient is negative because I have majority of my points in the second and the fourth quadrant when I standardized it. So that's the process of standardizing and thinking about calculating that R value by hand. So if you go back to your notes a minute, and let's do that right now together. So actually, the end of those notes, we'll talk about those in another video. I think we'll wait and do that a little bit later. Remember, so in this, actually, we just won't do this last part. So correlation coefficient here is negative 0.8, whatever I got there. Now, 884. And then I wanted to show you one other thing. So we could find that R value another way as well. If I wanted to, I could actually just calculate my line of best fit and do that by hand. So actually, I'm going to do that in another video as well. We're going to do that in one of our next videos. So I'll walk you through that process, but I think I gave you enough information for now. So hopefully this all made sense, and we'll talk soon.